Hello, and welcome to another episode of Hacking with Friends. My name is Cody Kinsey. I'm a security researcher at Varonis, and today we are joined by our resident cryptozoology expert, Michael.
Indeed.
Michael, thank you for joining us today.
Of course.
So, all right, today we have a continuation of a previous topic, which we covered basically creating a hackable router that you can set up, go after, and not have to feel bad about just really practicing a bunch of Wi-Fi hacking stuff on because it's running all on a $5 microcontroller. Well, this time we're going to go even cheaper, and we're going to try to set this up instead on an ESP8266 microcontroller, which I've been able to get for about $1.80 in bulk from AliExpress if I'm willing to wait for a while, but you can generally find for about $3 on websites like Amazon or AliExpress or wherever. So there's a pretty big difference between these microcontrollers in that this is this little D1 Mini here, which is an ESP8266 development board, is really bare bones. It can't do a lot of extra stuff. It's really limited on space, and it doesn't have the horsepower that the ESP32 has. So I was a little bit curious to see if we could get the same projects running on this. And I was also actually surprised to find that when we did get them up and running, they had about the same network speed as the ESP32 did. So even though we're using a much less powerful microcontroller here, we're actually able to get like 5 up, 5 down. Like, you know, not...
That's being generous, but yeah.
No, that's what I was averaging for a while. So like, you know, I found that we got worse speeds on the ESP32 sometimes. So I was actually kind of impressed by what we were able to get out of this little ESP8266. Now, I also found out that there is an Arduino library that supports this. So today, we're actually going to go through 2 separate ways of setting this up as a network extender. Now, one of them is a little more technical, I guess you would say, because you need to use like a Python tool to flash it over. And it allows you to have an access point where you can configure everything. So you just flash this, and then right from that point, you can connect to it. You can put in the access point you want it to connect to get an internet source, and then you can select what access point name you want it to create. So you can make a honeypot network that basically can capture people that are out there looking for a network to connect to and provide them internet while you snoop on them, or it can just be a hackable router that's internet connected and you can connect other devices too. So really, really cool. The other way of doing this is just using it as a straight up network extender via Arduino IDE. And in this configuration, if you're comfortable with Arduino IDE or if you've used it before, you can very easily set this up to extend your internet connection with a little bit more difficulty when it comes to actually setting like the network name if you wanted to customize that. Now, I've gone through and changed this in at least one version that Stefan and I are working on, where it allows you to control all the variables from one sketch. But frankly, after kind of looking at both, I think the future of this feature is going to be having a binary that you can just flash over, and then you can configure it from a web interface. Now, we're not going to cover it this time because it's not, I would say, quite finished yet. Although we do have a prototype up and running.
Is any project ever really finished, though?
Like this one, I think, is pretty straightforward. But what we're planning on doing, Stefan and I anyway, is creating a little tool that you can set up as a standalone kind of honeypot network that also runs the FTP honeypot that we showed on a previous stream. So the idea is you have this, you flash it over, you connect it back to your access point, and then you have a FTP server or a fake FTP server running on this little device waiting for somebody to connect. So if a hacker finds your access point and breaks in because it has a weak password, then they, on this little device, will see, oh, there's an FTP server here. They'll access it, and that will immediately trigger a Canary token, which will send you an email alert and say, hey, somebody's accessed the FTP server on the forbidden Wi-Fi honeypot network. So this basically is an all-in-one honeypot that would allow you to know if anybody is like connecting to Wi-Fi networks in your area and then just trying to access services. And provided you never, yourself go and try to look into the FTP server, then you should never trigger this accidentally. So it should basically never give you any false positives, which I think is really cool.
Yeah, and it would be cool to see if we could in the future add like other honeypots, like an SSH honeypot or something like that. I don't know if a microcontroller would be powerful enough for that.
Yeah, that one might be a little bit more difficult because at that point you're emulating a Linux system, and this is
Right.
not a Linux system.
Right.
So this can do like some elements or like run certain programs, but like
Yeah.
actually having like a full Linux system emulated behind that SSH server would be probably the more difficult
Or,
part.
or even if it could just like present like, oh, I have this stuff, and then see if people try to brute force it.
Yeah,
And then do
I mean,
something with that.
Yeah, it's definitely possible. So having other types of honeypots is definitely something we're interested in. Anything from like fake printers to you know other things that people might be able to exploit. But for now, we're just sticking to the FTP server just so that we can have the ability to either do attacks that are either any password. So if somebody just tries to connect, it'll automatically let them in and then trigger, or a specific password where we only want to know, for example, if someone's doing brute forcing. So it kind of allows us to set this up with relative sensitivity depending on what we're expecting. If we only want to see people that are connecting and brute forcing, like we basically want proof that someone is trying to break into something they're not supposed to be breaking into, then we can set up, you know, an open network with an FTP server connected to it, and then anybody that connects and then brute forces it, we know is out there trying to break into accounts and like would give us some information about what's going on.
That would be cool if it was like a reverse rate limiter where it always tells you the password's wrong unless you try to guess like over 5 per second or something, and then it starts telling you the password is right. Or it just tells you the next password is right to make you think that, oh, hey, I brute forced it. It was a really weak password.
Yeah, I mean, alternatively, you can just set a really weak password.
Yeah.
And you'll have
That's true.
Yeah, a similar effect. But I mean, this is a project that we just kind of bodged together between two different sketches, Stefan and I, like last night. So we're still kind of setting this up to be the most efficient setup, which is why we're not really going to go too much into it. But this is something you can do on top of what we're going to be showing you today, just getting a network extender set up to be able to provide internet access on a little microcontroller, and also to be able to do some of the cool attacks like, again, brute forcing. With this little device set up the way we're going to set it up, you would be able to connect you know, another device that has the FTP server connected to it, and then go over this network in order to attack it. So you would never need to involve like your home or your work router. You could do all of your networking stuff through this. And that's really why it's so cool, is because it offers like the kind of networking stuff that you just don't get on the typical soft access point. So it's worth pointing out that the soft access point that that these little microcontrollers offer up initially, when they're usually being configured or set up, only allows you to connect to this device. So if I connected two computers to the access point that this was creating, in most cases, then it wouldn't allow you to communicate between those computers because it's not acting as a router. What we're doing today will, and that's really what's so valuable about this project, is you can connect multiple computers to this, and you can communicate between those devices through this network. So that's why I think this is so cool. So let's take a look at the microcontroller we're working with today. We have this cool little microscope we never use. And so this is a close-up ESP8266 with its cap off. Scandalous. And you can see the wireless chips that are actually responsible for all the cool Wi-Fi stuff. So this is also a special model of ESP8266 that allows you, if you want, to mount a special antenna. Now, the ones that we're going to be working with today are a mix of the nicer ones. Our friend Alex Lennon calls these the D1 Fancy. But these are basically the D1 Mini Pros, I believe is what they're called on AliExpress. And what's cool about them is they have an onboard ceramic antenna, which I think is over here. Yep, there it is. So this is the onboard ceramic antenna. And this does a pretty good job. It gets like pretty good range. But if you really want to be a badass, you can instead do things the hard way and go over here.
A little UFL connector.
Oh yeah, so this little thing you see on the bottom actually allows you to put a little adapter and then mount any antenna that you want. But you have to switch over this tiny little 0 ohm resistor. So what the reason for this is, if you leave both the onboard antenna and the external antenna connected, they will cancel each other out or cause a certain amount of loss because they're connected to each other electrically, and it'll actually denigrate the overall performance of whatever antenna you connect to it. So you actually have to it's like turning a switch. You have to like heat this up with a hot air gun and then move the little resistor over in order to enable one or the other. And this is the size of a grain of sand. It's so small.
I wonder how much it would have really cost to just add like two little dip switches that you could just swap them really easily, as opposed to having to like go in and solder a microscopic
Honestly,
size
like
thing.
having like a pin out here that would allow you to like connect like a little bit of baud wire or something, just like something else would have been preferable, because this is an absolute nightmare to solder. But it is one of the advantages of the type of D1 Mini Pro is if you wanted to do something like this, but extend the range, you could put a big omnidirectional antenna on this. You could put a directional antenna that's pointing to a certain area. So it's really cool that some of these ESP8266 based microcontrollers allow you to be able to do this, because yeah, there's a lot of things you can connect to them in a lot of ways. You can actually make them more useful or more directional. And of course there's, hold on.
Yeah, I was going to say what's cool is that little UFL connector at the bottom. You can just get UFL to SMA, and then SMA is what you would traditionally think is your antenna connector, and that's where you can screw in. Usually an omnidirectional is going to be nice, but like Cody was saying, you can use a panel antenna, and that's going to give you a much more like directional cone, or a Yagi would also be a popular option.
So while if you're shopping for directional ESP8266 boards, there's also our friend Stefan's board that he made. After we had a conversation, I was just like, hey, could we make like a D-Author hardware variant that has the ability to add a directional antenna? Because like there aren't any that currently do that. And he was just like, yes, let's do that. So, well, our internet's going incredibly slow, but if it ever gets there, another thing you can do is go to spacehoon.store, and you can find a bunch of different hardware devices there. But the one in particular you can check out is the Andromeda D-Author. This is a prototype that features a really easy to swap antenna. So instead of needing to do this soldering, you can go ahead and just buy it here. Actually, I think it's very slowly loading, but you can switch over to my screen, and you can see over on the left is the D-Author Andromeda. Super cool. I was involved in the design of this just because we wanted to be able to make it easier than like flipping this like tiny grain of sand resistor. So you can pick one up. If you're in Europe, you can pick one up at spacehoon.store. If you're in the US, you can pick one up at hack.gay. But either way, really cool project. But again, you can also just pick up a D1 Mini Pro if you want to be able to swap out the antenna. So we don't usually feature these all up close and stuff, but it's kind of cool to see the actual board that we're working with today, because again, these are super cheap. Like you can find them for around like $3, and it's great to be able to work with that. But again, if you want a fancier one that's a little bit nicer and maybe like has some additional features, then definitely check out the Andromeda D-Author, because you can also support the creators who make the software behind a lot of the stuff.
Yeah, and actually, right, I don't know if I can get this picture bigger, but you can kind of see in this image here, that's the UFL connector to SMA, and then that's just your traditional antenna access.
Yep. So, okay, so I was pretty excited to find out that when I was working with the previous version for the ESP32, it involved like flashing over it using like a Python tool and some other stuff that might not be as familiar. And I know a lot of people have maybe tried out Arduino IDE and might be a little bit more familiar with that. So, which is kind of funny, although, because like Arduino IDE actually uses that Python tool to flash over when it's done compiling, but whatever. But I was just excited to see that this is actually available as a library, or at least there is a feature now that is supported by default in the ESP8266, and there's some good example code. So if you just want to take a example of this just Wi-Fi extender without really messing with too many of the features, you can get this up and running relatively quickly in Arduino IDE without needing to do very much setup or changes. So last time we showed the ESP32, which was also by Martin Gurr, who is from Germany. So I'm sure Stefan will be proud of that.
Is it just like short for Martin Germany? Gurr.
Well, it would be like Deutsch or something, if that were the case. So no, I don't think so. But yeah, so he has made another project that applies to the ESP8266 that can be flashed over relatively easily and basically has all the features I was talking about, except for the honeypot feature, which I still want to implement. So what's cool about this is you can just take the project folder here, and after flashing it over, it gives you all of these options in a web interface. So Literally, it's like you plug this in,
Mm-hmm.
you flash over the binary with one command, it finishes and creates an access point. You connect to it, and then boom, you have this screen.
Mm-hmm.
So at that point, it's like, all right, well, what do you want to connect to? And you can also set up auto mesh. Auto mesh is a feature I'm going to
hey.
probably show off on another episode. We might try it out today. I'm not sure. Probably not. But it just depends on how many D1 minis we have handy. But auto mesh allows you to mesh as many of these as you want to create a clone network of whatever it's connecting back to. So you can kind of think of it as if you had like a hotspot on your phone, which had data. You can connect one of these, which is going to take the network name and password of your phone and apply it to itself. So it's going to create basically the exact same network. Now, if there was another D1 Mini flashed and set to auto mesh, it will detect that and then do the same thing. It'll automatically connect to it and create the same access point, and it'll keep going and going and going. So if I have 12 of these down the line and Michael is, a quarter mile away, he can't connect to my phone's access point. It's too far away. But through a chain of D1 minis, all auto meshing through each other, he would be able to connect back to the phone. And with a little bit of lag added from adding all these extra routing points, he would be able to connect back and get an internet connection.
I was gonna say, yeah, just kind of visualizing what that looks like generally.
Yeah, kind of like the second one, like the messy one.
Like this one,
No, like the one on the left.
this one. But yeah, so mesh is also really
Sorry, I'm allergic to that color.
okay. But yeah, generally a mesh is very useful for extending range and providing access in places that you would have trouble running like an Ethernet cable to or otherwise getting access.
Yeah, so there's some other cool stuff here. You can set the access point settings as well. So let's say that you want it to be something different from the name and password of the network that you're connecting to. You want to maybe have this be a distinct network that your IoT devices or like some honeypot devices connect to. Cool. Well, you have complete control over that. You can set the SSID to be something different. You can set the password. You can set the security, WPA2 or open. Those are your choices. Can't do WEP. So a little disappointing because it would be kind of cool to make like a WEP honeypot, but who wants to go through the trouble of implementing a completely obsolete security standard? Then you can also lock the configuration. So let's say you wanted to use this as like a guest network because you hate your guests. You want them to have the absolute you want them to have the absolute slowest defensible speed. You basically want to kick them.
So basically you're an airport Wi-Fi.
Yeah, you want to basically be no, this is going to be like the airplane Wi-Fi.
Yeah, okay.
Is like the kind of quality and speed you're going to be delivering to
The
your guests at this
airplane
point.
free Wi-Fi.
Yeah, again, if you hate someone, you can be like, hey, I set up a guest network, and they can join it, and they'll be like, this is the absolute slowest internet I've ever had. I can stream like one YouTube video if I close everything else out, and you'd be like, oh yeah, the router's kind of slow, whereas your router's actually super blazing fast. So yeah, if you want to make like a mother-in-law network or whatever that or your kids have been misbehaving network. And force them to connect to it, then you can absolutely just create a network that is so slow and intolerable that it will let you join the internet and do some basic stuff, but you would expect it to be like a Netgear router from 2001 that was delivering it. So hilarious. I just thought of that application. I'm actually pretty proud of it. As the mother-in-law network as it was, just someone you want to go away.
Yeah.
All right, cool. So there's a command line interface here.
I guess it also would be a cool way to segment off your IoT products, maybe. If you just created one of these.
Anything that doesn't require very much bandwidth, is absolutely going to be a good fit for this. So if you have anything that's just running relatively infrequently, then absolutely this would be a good thing to connect to. Like automated sensors, anything like that, would be a perfect use case for this. Streaming video, you could do it. We haven't tested it, but it would need to be low resolution in order to be reliable. All right, so there are also some command line interface options. Basic commands are here. Advanced commands. Some of you nerds were asking about routing and stuff. I haven't gone into this, but if you want to go through auto mesh configuration, Wi-Fi configuration, static routing, WPA2. If you want to set up WPA2 enterprise, connect this back to an enterprise network.
That's
cool.
cool.
So you said, ooh, I'm assuming because you think that means we can set up WPA2 enterprise on this.
Oh.
No, we can connect this to WPA2 enterprise.
That's sad.
Yeah. I too was excited. I might be wrong on this, but I believe that is the case because I looked this up and the documentation was all like how to connect it to a WPA2 enterprise configuration. And
well, and it would have to be running a Radius server too, which I think would take up a substantial amount of this little microcontroller's brain.
Yeah, exactly. So then, you guys were asking about routing. Here it is. Boom. You can do routes. You can set static routes. Cool. Enjoy all that. You can do the firewall and monitor configuration. So you can do ACLs and all this other fun stuff. Enjoy that. User interface configuration. So you can set the port number. You can set the port number for the web server. And then you can also set the access mode, which controls networks configuration access. So 0 is no access, 1 is only internal, 2 is only external, and 3 is both. So if you want to disable this so you can only control the configuration through the serial interface, you could basically lock this down and make it so that anybody on the network isn't able to go to the web interface and just like liberate themselves onto something else, or like unrestrict certain settings you'd set. So this would prevent somebody from taking it over, but it's also substantially less convenient. But again, if you wanted to set this up as like a guest network and then lock it down, then this was something you would want to do. And you can access all these configuration settings through the serial interface, which is pretty cool. You can do that through Arduino IDE, or you can do that through just using like Screen or something. Cool. It's got a status LED, so you can see like network lights when it's going. And also it'll allow you to know like what kind of failure is happening if you don't have any serial connection. This is just really cool. I really like it. And this is a much more tasteful example of mesh routing.
Oh yeah, can I just note how well documented this is?
Yeah, I don't mean to be racist, but Germans just are really good at documenting project, or at least several of the Germans I know. They just seem to really like not want to like do a project unless it's like documented correctly. Like, and I really appreciate that because mine are a mess.
I will admit I get really annoyed with GitHub projects that have like a 3-sentence description, and then they're just like, just read the source code if you need to know how it works. I'm like, yeah, thanks, bud.
Yeah. Even 5 ESP Wi-Fi routers in a row works pretty well according to the documentation. And seriously, like I have to give a lot of props to Martin for making this super understandable. Previously, I'd only seen examples of this that were just absolutely crazy to flash. They required you to use like Espressif's like weird program that you have to have Windows to do. This this guy like documented it so you can just run this with a Python program. And I think that that's so valuable to have created something that's just out there for the community and available to be done by people who are not experts. I don't consider myself to be a big time microcontroller expert. I just have basic experience with them. Stefan's much more advanced than I was, and he still was put off by a lot of these projects. So it's really cool to see this so well documented, and also I think like updated recently, like months ago. So yeah, this is like an actively maintained project that I really like, and I'm just so blown away by, because it's just like every time I describe the way I wish it would work in the Arduino implementation, it just is this project. So the only thing I would change is the honeypot thing I'm trying to do. But aside from that, this is just a really great version. But we'll go through both versions. So let's go ahead and then get started. So let's talk about how to flash this over. There's so much documentation here, but I'm going to look for ESP tool. And here, tucked away, you'll see the documentation for what we need to do to flash this over. So flashing and building. Or building and flashing. If you have Docker installed, which is a nightmare on a macOS system, the easiest way to do this is in your build environment. So you Docker nerds, go for it. Like Dock all day. You can just do this and
containerize all day.
Then you're good to go. I don't know what they call it in their private circles, but it's fine. So that's one way to do it. I have had a hard time setting up Docker on this macOS system, so I instead am going to be using the ESP tool. I love that this is documented like so low key, because this is absolutely the best part of this entire documentation page. And
it's just like one random
sentence. It should be in
sentence.
all bold with giant arrows pointing to it, because this is absolutely the easiest and best way to do it. In fact, like there may be a way to do this from a website that Stefan and I are working on. So like you literally on the website would be like, flash this code over to this microcontroller, and it just does it for you.
And it just runs the Python
Yeah,
code.
as opposed to like downloading this, this completely whack tool that Espressif makes that looks like
something
what is
from
this?
the 1990s?
It looks like it was made in 1999, yes. So I hate this tool. I absolutely hate it. Like, I'll learn to use it at some point, but like, I hate it. This is a great software tool that anybody can use, and I think it's like pretty straightforward. So that's what we're gonna do. First, we need to download this. So we'll go to the very top up here and click on code and then download zip. Then we will open the zip file just so it expands into a directory. And then from a terminal window, we just need to cd into that directory. I'm already in the directory, I believe. Yep, I'm in the ESP Wi-Fi repeater master folder. And then the command here is going to be esptool.py, the port, which, oh, I need to actually get the port number. But we'll put the port here if it hasn't changed. Then write flash, fs, which is, it's going to indicate there's 4 megabytes of flash memory. Blah, 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 blah. And then we're basically going to be flashing over these. That's a memory location. We're going to be flashing over a bin file. Actually, I think 2 bin files from the directory to 2 specific memory locations. And that's it. It's a really short command. Like, there's not that much to really do here. So in order to make sure I have the correct port, I'm going to go and type ls dev su, which on a macOS system will just tell me all the stuff connected to serial. I can see this is the correct serial port, and these change like so often. So I'm gonna go.
I think your screen is frozen.
Oh, so I'm gonna go over here, and I'm gonna make sure that this matches the serial port that I just found. And as soon as I confirm that it does, it actually looks like it does exactly match, but I'm so paranoid. I'm just gonna go ahead and do this. As soon as that matches, I should be able to just directly flash this little D1 Mini that I have connected. So let's go ahead and flash its brain. So this is what I'm talking about when I say that this is just incredibly easy to do. Like, you know, I downloaded the zip file, I opened the zip file, I changed directory into the zip file, and then I ran this command. And as long as I have the correct port here, then it's just this easy to flash this program over. Okay, so now that we've flashed this, there's a bunch of different ways we can connect to it. But because for whatever reason our serial terminal is not allowing us to show it on our video capture, I'm instead going to use SpaceHoon's really awesome new project, the SpaceHoon Navigator. So this is, of course, in beta, but this allows you to connect to a microcontroller, and it's supposed to be connecting to the dauthor project, but instead I've connected it to the NAT router project. So I'm just going to go ahead and actually show you how this works. I guess I'll just refresh it. So I'm going to click on connect. I'm lying here. I'm not actually using the dauthor v3. Please forgive me, Stefan. But then I'm going to select this one right here. And if I press the reboot button, I should see the output. That's telling me everything I need to know about it connecting, scan
So
done.
in theory, this works on any ESP82.
In theory, what works?
Just this interface, this navigator.
The navigator, no.
Okay.
It will only work on ESP8266 program, which use a baud rate of 115200.
Okay.
If it uses a different baud rate, then you are out of luck.
So if you have a ESP project that happens to use that exact baud rate, you could, in theory, use the navigator on it.
Yeah, if you just need a simple serial interface, yes. And this is done, again, through a website, which is super cool. So here we can see that it is connected, and it has now set up its interface. So what I'm going to do is I'm going to reach over and look on Wi-Fi to see if I have any networks. Let's see what we got available. We have one that's just called Slowzy. Okay, maybe that's it. Wasn't kind of expecting that, but let's check it out. Oh, look, we can see that something just joined it. So we can see, in fact, yes. I believe that's a prior configuration I set. So one thing that's interesting here
That's a great name, though.
is sometimes if you want to fully flash this over and not have weird like remnants of like a previous configuration, then you actually need to do a full erase first, which is something that they don't always tell you. So in this case, it looks like this has chosen to keep my previous configuration. And if I want to connect to it, I can see I have an IP of 192.168.4.1. Cool. I'm going to go here and then connect there. And we can see we have a ESP NAT router configuration page that we can now set up to, oh yeah, I mean, you can see that I set it to slow Z earlier.
Nice.
So that's funny because like I would not have expected that to. You can see there's some like errors going on here because
Yeah.
it didn't fully erase the chip beforehand. So that's actually kind of funny. I wasn't expecting that. Now I'll leave it on this. Let's see if it works. So we have a network called TargetNet, and we also have a password set. So let me make sure that that matches up to the hotspot. Yep, I have one device connected to the hotspot. So this now should theoretically have an internet connection, and it's offering up the SSID of SlowZ. And no password, which means that, of course, we're not going
It's
to...
the most secure network in the world.
Right.
Yeah.
Sure. So, what's your favorite, again? Speedofme.com. Isn't
Yeah.
that the one you use?
Yeah.
I have no
Although
idea.
the Google, just like the Google browser one, you just search.
Like the speed test? Yeah.
Yeah.
Yeah, the speed test one is the fastest to load. I don't know why you like Speed of Me so much. Why?
Because it's pretty. That's why.
Right. Okay. Well, I'm just going to go ahead and use this one. Bink. Because it loaded immediately. I guess all those graphics just, slow it down. Well, maybe I spoke too soon when I say it loaded immediately.
Maybe this is aptly named when you called it Slowzies.
Yeah, so this is definitely not the fastest network connection I've ever been. And again, it's also, like, this didn't fully erase itself, so it's kind of funny that it has, like, partially configured settings. This is incredibly slow compared to, like, last night. Last night it was getting, like, 5. So, like, this is bad. This is not a good connection speed. But, what are you going to do? Like, I would say if I fully erase this, I might expect to see a little bit better speeds like I was before.
I think that's the slowest number I've ever seen on one of these tests.
Yeah, I'm really interested to say like what this is good for because it's always like, you could like browse one YouTube video. It's gonna be like you could listen to one MP3. Your connection is very slow. Web browsing should work, but videos could load slowly. Yeah, so we have this set up. We can do routing through it. We can do other stuff through it. And we can see here that we can do command line interface things through this as well. So any of the commands that were available via the project, you can see here. You can just go ahead and put them in and, have them have whatever effect. Like if I want to set the access point on or off, if I want to set the access point to open, all this cool stuff. So, all right, that's pretty straightforward, pretty easy to do. And my favorite thing about this also is, again, like you are just dealing with this web interface where as soon as you have it up and running, then, you're basically set up for...
Okay, never mind.
Yeah. You're basically set up to be able to work with this immediately. So, all right, now I'm going to risk it all, and we're going to try to do Arduino IDE. So we've experienced a tremendous amount of system instability today. Some things will just not show up on the screen. Some things will not capture. So hopefully Arduino IDE is among the things we can show because this is being very temperamental today.
Yeah, and every time we try to mirror his display, Arduino crashes.
For no reason. It's very confusing. So yeah, we're going to go ahead and try to use, once it opens, yay, you can see it. Arduino IDE has this sketch called Range Extender. So we're going to go to Preferences. I'm going to beef this up so you guys can see the code a little bit better. Let's do maybe like 20. And here we go. So I don't believe this is the modified version. Nope, it is not. So if you have the ESP8266 package installed, which you do by going to Preferences, going to Additional Board Manager URL, and then adding this, let's kind of make it bigger. Adding this Arduino ESP8266 stable package, blah, blah, blah. Got to add this, which will allow you to see all the ESP8266 libraries and packages. And from there, you can just go to Examples, and then go down to ESP8266 Wi-Fi, and you should see this range extender napped. I wish that this was, I don't know, I guess that's kind of like clearly marked, but like still, the fact that this is acting as a router is like pretty cool.
I was going to say, it's nestled in a bunch of other boards.
Yeah, that are like, well, it's not boards. These are just example sketches of
yeah.
how to do different things on the ESP82s. There's also like Wi-Fi mesh, hello mesh, and some other cool stuff. But we're going to select this range extender here. And this is just the default configuration. So we're going to make this target net. And one thing I don't like about this is it requires you to hard code the credentials. It doesn't have an access point for you to be able to add these. So I'm going to confirm my password.
Yeah, and then in theory, anyone that were to pick up this device could just in plain text see your password.
There's no difference between this and that. Because as soon as you configure it via the web interface, it's going to be storing it, and you could probably extract it there too. But in this case, like, you do have to program in the SSID and the password for the network you want this to connect to. So then we'll go into tools. We'll make sure that we are connected. Oh, I think I actually have to disconnect from the navigator to be able to write to this. So let's go ahead and do that. I'm gonna go from connected to disconnected. Look at Stefan. so clean to get to that. It's so intuitive. Good job. And then we're going to go ahead, make sure that this has selected the correct port. We can see it's selected this port. Yep. We're going to make sure it's on the board, is set to the Wemos D1 Mini, which it is. And then we should be able to go. So I'm going to go ahead and flash this over. And if we are lucky, then this will also allow me to watch over the serial port, and we'll be able to see what's going on with it. So this is flashing, still flashing, flashing more. So, all right, this was pretty easy. We can see it's done uploading. I can press Command-Shift-M, and we should be able to see this configuring itself and setting up. All right, we've got a station. All right, so it says that it's creating target net extender with the same password as now netted behind target net. So, okay, basically all this did was it extended this, added the word extender at the end of it, and then used the exact same password it had configured. Not very creative, right?
Yeah.
Yeah, so like, okay, let's go ahead and test this, and then I might make a small modification to see if we can make this a little bit better. So we can see target net extender. I'm automatically connected, and it's just using the exact same password as target net, and now we are connected.
Oh, okay. Yeah.
Or at least we should be. Let's see. Are we? Yeah, I think so. I
mean,
didn't see any output here.
Target net extender and all that makes it easy to find. But
it does. It does. So I'm going to ping.
But it doesn't.
1111.
I thought it would use the exact same SSID so that your device would seamlessly transition between the two networks based on what connection was stronger.
It's confusing to do that, and I think they decided to just make it an obviously different network because this works for most people's use cases. So one thing you'll note is like there's no ability to set the network name to something different. So if you wanted to set this up as like a honeypot network or something, then this doesn't really let you do that, does it?
Yeah.
So I thought this was kind of like a missing feature. So let's go ahead and just add it, right? Why not?
Sure.
Okay, cool. Let's do it. So I'm just going to go ahead and create some new variables.
And then you're just going to...
AP SSID, AP pass.
I was going to say, couldn't you just find the line where it appends extender and delete that?
Yeah, but then you would be creating the situation which you specified, which I said is confusing. Most devices can't distinguish between the two.
I see.
So if you wanted to connect to one but not the other, you would have absolutely no way of distinguishing them.
Okay.
So like if you wanted to create a mesh network situation, this is not set up to do mesh networking. So it wouldn't be auto meshing. You would have two totally separate networks.
Oh, so this... Okay, so wait, this isn't the one we were talking about earlier that does meshing.
That was the one we just switched away from.
Okay, gotcha.
Yeah. So the one with the web interface allows us to do auto meshing.
Okay.
This one does not.
I see now.
Yeah. So we have a couple new variables. We have the app SSID, and then we have the app ass, which is the the password. So let's go ahead and do that. So now let's say that we want the app AP SSID, or let's make it the AP name for our lay people.
Yeah.
Let's make it honeypot. Let's make it lowercase. And then for the app-ass, let's go ahead and make it honeypot. Right?
Yeah.
Yeah. All right. So
that's a good honeypot name.
Yeah. So
they'll never suspect it.
Exactly. So we're going to take the AP name and let's look around in the code and find out exactly where it's doing this. So we can see, we want to just look for the name extender.
I feel like that would be another good name, is like FBI surveillance van. No one would suspect that's honeypot.
That is such a dork network name. Like maybe in 2001, That would be cool. All right, so here we can see the part of the code where it's creating the station. And it's basically saying we want the station ID and then add the name extender and then set the password. So let's change this. We're going to instead make this the AP name, and we're going to make this
wait, how did you do that in one
I
click?
pasted.
Oh, okay.
And then I'm going to make this the app-ass. So now we have our password set, we have the AP set, but we do have this last part down here that's outputting over serial, which now makes absolutely no sense. Because it's saying the Wi-Fi network, blah, with the same blah. So let's fix our documentation. Wi-Fi network with, it's not the same password. We're going to do some string replacement. Is now natted behind lap. So right now it's saying, it's just the output here is taking the exact same network name, adding extender, and then saying it here. So let's change this again. So we're gonna say Wi-Fi network name and then the new network name. So that's gonna be AP name, and we're gonna get rid of extender because that's not part of it anymore. With password, which is now different. So we're gonna put this in here too. So comma app-ass. And then comma the station ID, which is fine, is natted behind the station ID. Okay, cool. So this looks like standard string replacement. We have now fixed this. Is there an extra space here?
Very professional coding.
Yeah. I mean, it works, right? So let's see if I've messed anything up. I'm going to check to see if it compiles. All right, so we've basically just taken this Arduino library and we've customized it. We've added the ability to customize the access point name that it's creating, and you can do this too. It just took me a second to do this. You can just follow along and, you know.
And I think this really demonstrates, like, when we have people in the Q&A asking if they need to learn programming, like, I don't think you need to learn all of programming, but knowing a little basic programming so that you can look at something like this and just like tweak a couple things to work more like the way you want it is a really valuable skill to have.
Yeah, absolutely. Like this was the result of like taking like 2 semesters of C++. So,
Right.
All right, so I'm gonna go ahead and upload this. It compiled, so it looks like my modification fork, some might call it, of this code is working. So we are uploading. It's done uploading. I'm going to press Command-Shift-M, and then let's see if our modified confirmation message will tell us what we want to hear.
I really don't.
All right, so we've got that. We've got Wi-Fi network honeypot with password honeypot is now natted behind target net. Hey, we did it, right? All right, so now let's go ahead and see if we can connect to this separate network and still get an internet connection. At that point, I think we can call it a day. So, all right, so we have honeypot. We're connecting to honeypot with password honeypot. It's already stored because I did this earlier. And I'm going to wait a second. Just wait for it. And I'm going to then see if we can. I'm going to attempt fate, try to ping. And there we go. We got a heartbeat.
Hey. I was going to say,
we got
that
a timeout
is
and then a heartbeat. So there we go.
Very hectic pings there.
Yeah, it's all over the place. So we can see that with this Arduino Flash version, we're getting pretty similarly terrible
Look
speeds.
at those flames coming out. It's so fast.
It's getting hot. Again, like I was able to get better speeds when I wasn't connecting it, to my phone's network, and I was connecting it to like, a coffee shop network or like an actual access point. But hey, for just being able to connect this to a phone and then offer very, very, very basic
I feel
internet.
like this would make great coffee shop Wi-Fi because it's long enough for people to think it works, check a website, and then the second they try to sit down and relax and watch a YouTube video, they'll be like, oh, I've made a grave mistake.
I must move on.
Yes.
Yeah. So if you wanted to just like get someone to leave, you could set this up with the exact same like configuration as a good network, and then like surreptitiously kick them off of the good network onto this terrible network, and they'd be like, "Damn, the internet sucks here," and they would have probably no idea that they'd just been moved over to like an evil access point that's just very slow.
Yeah.
So. Yes. So, hey, I mean, it looks like it works, though. So we were able to modify this sample code in order to change things up and actually, like, create a custom variable, which then was the access point name. So this allows us to create a honeypot network, a separate network. And, I appreciate the developers for making this code and making it easy to just set up a NAT router, like, that quickly. But, hey, like, or a network extender, I guess would be the proper way of saying it. But sometimes we want to customize the variables a little bit, add a little bit more, and have more ability to change stuff. So with this additional set of variables, you could go ahead and do that. Now, Stefan and I have also been working on this custom version, which is really cool. And it basically incorporates all this stuff. Oh, I used NewPass instead of AppAss. I should change that. But anyway, it has the same little twist on it that allows you to customize setting up what it's going to be, but also allows you to set a Canary token. So here we have the ability to set up an FTP server, a fake FTP server, and then have it basically ping us when anybody attempts to access it. And we can either set a password that people have to use in order to get in, or we can just use the % in order to accept any password. And we can just make this so that either it accepts any password for just admin or any username or password. So it's really a lot of customization you can do with this.
And if you don't know what a Canary token is, we do have a full live stream on what they are and how to use them. But they are incredibly useful for these sorts of situations where you need to track, when something's opened.
Yeah, so we're gonna do a separate stream because I love this on this specific sketch where we're gonna set this up. We're going to scan for it, and then we're gonna attack it, and then we're gonna look at tracking as well and show exactly what we can see. I think this is worthy of like a little CTF, honestly, because it's so easy to set up and run. So yes, definitely stay tuned for that, and hopefully you guys like this particular series because I think it is so much easier to get this project up and running than I initially thought it would be. Like, just showing you guys 2 separate ways of doing this has not taken that much time. We've been able to get an internet connection on our little microcontroller, which is pretty wild.
Internet connection.
Hey, I was able to go to mydoogle.com as well as many other websites. So I will say this worked pretty well. But yeah, your results may vary depending on a couple things. One thing I will say is erasing the chip before flashing it is a step that we kind of left out here. And you could see the results where there were some stale configuration settings left on the chip. So I always recommend before actually flashing this, even though it's not included in the instructions, actually erasing it beforehand because it can cause some issues if you do not do that. Yeah.
Or you can use Cody's strategy of buying 100 D1 minis at a time and then just flashing new ones each time.
That would also help. But yeah, in general, like, I've come up with a couple of different ways of like fixing this. In particular, there's like a, oh, can I open it? There's a bash script that I've written that basically, I also have this on GitHub, that basically before I flash anything over, will first completely erase it.
Nice.
So you can see like this little command right here, with the exception of the $ thing, which grabs the port, will just completely erase the flash memory on the ESP8266. So if you're having all these like weird side effects and whatever, you can always go ahead and just flash it first. So, or erase it first and then flash it. So yeah, that's all we have for this particular episode. Now, some things that this can do. You can connect multiple devices to this and then communicate with those devices through this little ESP. And you can also kind of bodge together other libraries for the ESP8266 that might allow you to offer up, in this case, an FTP connection, or maybe like Michael said, you're able to figure out how to get an SSH server or something that looks like it. You can definitely get Telnet running. So that's something
like
you can
Telnet.
add.
I don't know, like DNS or like some. I'm thinking
DNS is not a service you can log into really, but
yeah. Well, anything that would be like very appetizing to a potential attacker would be a nice addition.
Yeah, like a web interface with like a router login looking thing or something like that would probably be a good way of setting up some additional honeypots. Now, another thing we were going to say is we were going to put a file into the honeypot system that has a honeypot in it. So if you download the file and then open it, it calls the honeypot server from the attacker's computer after they download. So we would be, we would be able to get their IP address as well.
That would actually be really cool.
Layers within layers. So maybe we'll talk to the people at Thinkst because they're really cool and they've lended us some excellent experts to talk about all the different ways you can use these Canary tokens in sneaky ways. But yeah, so for this, like we've gone over how to take the price down on this awesome little network extender / NAT server or NAT router by like a good $3. So I
mean that's like half the price.
Yeah, and frankly the The auto mesh feature in Martin's version is so much cooler, and the web interface, I think, is so much more intuitive to set up that I would honestly recommend Martin's version. Like, even though this is now built into the ESP's like library, and the example version, as you saw, was pretty easy to modify, I still really like the way that he did it, where you just flash it over, and then the web interface lets you set up all the variables yourself. I would just love to add like the ability to add like a Canary token.
I was going to say, so this FTP modification, have you done that with Martin's version
No.
yet? Okay.
No, because Martin's version is much more involved, and you actually have to change stuff with your build environment in order to compile a binary. So the difference
gotcha.
is, like, if you want to run the Arduino version, it's really easy to compile it yourself because you can just do it in Arduino. If you want to run Martin's version, you got to change some stuff over that a beginner might mess up. So it's a little bit, it would be better if if Stefan and I came up with a version that was good to go and then gave a binary to just flash over via the web interface. That would be the easiest way of doing it, because then you just set it up through the access point and flash it over once through like a website after connecting it. That's like the easiest experience I can envision. So
yeah, and I think really one important takeaway from this is just the fact that it can be really easy to take two projects you love and combine them together, especially when they're Python or Arduino or something like that that's fairly approachable. I think Python's more approachable than Arduino, but nevertheless, you can still combine things without having to know a ton of coding.
Yeah. Some of it's just kind of common sense. All right, so that's all we have for this episode. If you guys like this, let us know in the comments. If you have other things you'd like to see with these microcontrollers or NAT routers, also let us know. We love getting suggestions, and a lot of these episodes have been based on suggestions you guys made, so please keep up the conversation. And yeah, if you want to see some other great Varonis content, make sure to check out Threat Update with our co-host Killian. You'll see that on the Varonis brand channel, and they talk about attacks that are ongoing, which you probably have heard about in the news, and how real companies are responding to them. So
awesome.
Hopefully we'll see you guys next time and have more great content. We're going to be covering this honeypot, so if you have any feedback on that, it's an ongoing project, and we'd love to hear what you think, and we'll see you next time. Bye.
Awesome.